While digging around on the internet one day, I came across a science story that I think you might be interested in. We're talking about a life form that survives under seemingly impossible conditions. I have discovered Kiwa tyleri. That's the genus species name for the Yeti crab. Its existence was determined only 5 years ago, named for the legendary shaggy snowman of the Himalayas because of its hairy appearance. We are about to embark on a deep-sea adventure that will require some very deep thinking. At the very end of this video, I'll try to surprise you with what I think this whole story means. See if you can predict my conclusions. Are you ready? Let's go. Besides some warm clothes, you'll need two things. A marine biologist has a college degree in biology, so here's your diploma. And here's your airline ticket to get you from Michigan to Rio Gallegos, Argentina. This is where you'll pick up the subsea support vessel. Plan on spending about a month on this ship on cold, rough seas. The Yeti crab lives on the South Scotia Ridge between Argentina and Antarctica at a depth of 8,500 feet. That's more than 1.5 miles. To give you an idea just how deep that is, imagine you're diving down the depth of a football field. Pretend this is you. Follow the blue arrow and you can see your size compared to half a football field. To view the Yeti crab, you have to go down an amazing 28 football fields. There's one other problem. The deeper you dive, the greater the deep sea pressure. When you're sitting on the boat at sea level, you experience 1 atmosphere of pressure. That equals about 14 pounds per square inch. For every 300 feet you dive, or every football field, the pressure increases another 1 atmosphere. The Yeti crab lives where the pressure is an incredible 29 atmospheres. That would be like an elephant standing on your big toe. If you send a submersible vehicle that deep, you should build it with the titanium steel to withstand the crushing pressure. By now you're asking how those soft little squishy crabs manage to withstand such pressure. Simple. They grew up down there and adapted, having the same pressure inside and outside their body. When we reach the South Scotia Ridge, we'll be deploying an ROV, or a remotely operated vehicle. The ROV has all the necessary tools: robotic hands and arms, television cameras, and spotlights, so we can see the ocean floor and even take samples for analysis. As we approach the seafloor, we discover giant plumes of what looks like black smoke flowing from chimney-like structures. These are called hydrothermal vents, and this is where we'll find the Yeti crab. Hydrothermal vents are like volcanoes, spewing mineral-rich steam at temperatures well over 720 degrees. The Yeti live right on top of these chimneys. Let's make a visit. Climbing on these chimneys are massive piles of Yeti crab. They're drawn to the spa-like temperatures and could not survive in the frigid temperatures just a few feet away. Not only do the hydrothermal vents provide the perfect temperature, they also provide their only food source. That steam that exits from the vents contains organic and mineral nutrients considered to be the basic building blocks of Earth's earliest life forms. Many scientists believe that life on Earth may have begun here. In this case, microscopic bacteria, some of our most primitive, simple life forms. thrive and multiply here. The bacteria grow where the temperature is warm and the nutrients, especially sulfur, are available. Here you see how fast the organisms multiply. Before long, sheets of bacteria are found on the vents, available as food for the Yeti. Unlike other crustaceans like shrimp and lobster, the Yeti crab consume only bacteria. In fact, they've evolved to actually gather and farm the bacteria. The Yeti is covered with hair-like structures called setae, even on its chest. As they drag along, their hairy body acts like a Swiffer mop, collecting the bacteria and growing it right on their body. Another adaptation, unique to this species of crab, are specialized hooks on the end of their legs, perfect for climbing on the chimney. Their survival as a species meant overcoming another obstacle. Only the adult Yeti can survive in the sulfur-rich environment of the chimney. The crab eggs and even the juvenile crabs would die there. When the female lays her eggs, she must be a few meters away from the chimney. The cool temperatures quickly kill the bacterial food supply on her body. She begins starving and will soon die after laying her eggs. The newly hatched babies quickly make a run for it. They've got to get back to the chimney for food and warm water before they too die. Keep in mind, these little crabs have no eyes and are completely blind. I suppose it wouldn't matter because it's completely dark down there. And now you know the story of the Yeti crab. I hope you're as amazed as I was how a species can adapt to even the most difficult conditions. But for me, the story doesn't end here. I keep thinking about those tiny little bacteria, thinking that they evolved first at that location, perhaps with a perfect combination of temperature, geothermal energy, and chemical combinations of hydrogen, sulfur, and carbon that the hydrothermal vent supplied. Scientists believe that this may be where life on Earth first began. What if those same conditions occurred someplace else? Perhaps someplace far away. So I put on my thinking cap and got to work. See what you think about this possibility. The fifth planet orbiting our sun is Jupiter. It's big. 1,000 Earths would fit inside Jupiter. Jupiter has more than 67 moons. Take a look at the fourth largest moon called Europa. It's about the same size as our moon. Here's what we know about Europa. Its core is probably iron and sulfur, and likely molten. Above its rocky mantle is a vast, deep ocean of liquid water, up to 90 miles deep, and a crust of ice about 7 to 15 miles thick. There are even scars from comets that have collided on the surface. Recently, the Hubble telescope captured images of Europa that demonstrated active plumes of ice water erupting from the icy surface. This may be the first evidence of the existence of hydrothermal vents outside of the Earth. Now put it all together. Hidden beneath Europa's icy surface is perhaps the most promising place in our solar system beyond Earth to look for present-day environments that are suitable for life. The Galileo mission to space found strong evidence that a subsurface ocean of salty water is in contact with the rocky seafloor. The cycling of material between the ocean and the ice shelf could potentially provide sources of chemical energy that could sustain simple life forms. If Europa has an ocean cookpot containing the inorganic ingredients, oxygen, hydrogen, sulfur, iron, and an energy source from the hydrothermal vent, all it would take is a carbon source to ignite the fire of life. We have evidence that comets have collided with Europa, and we know that a 3-mile wide comet would be capable of crashing through the icy crust and could supply the ocean with organic material. If life is possible on Europa, it would probably start first with simple structures, slowly evolving to more complicated organisms. Think about this. There are billions of star systems out there. It's not hard to imagine the existence of life somewhere in space.